Hello friends, in this video I'm going to show you how you can have a well-done calibration for your scanner to get accurate alignment and results. Here I'm going to use my 50mm calibration panel. I made a wooden frame for it to protect it from crashes. And this is the calibration panel holder that I made by CNC milling. It helps to hold the panel in different angles easily. During this video, after calibration the scanner, I also scanned this black holder to show you how you can easily scan challenging black surfaces in the FlexScan3D software. Now I start on the software side. As an abstract, how to create a new scanner and select cameras and adjust the brightness of the cameras. On the scanner tab, I remove the current scanner, then create a new scanner and I select the advanced scanner type. Then by clicking on the camera selection buttons, I select the cameras. I have 6.2 megapixel Dahen cameras. I switch to the D-shot type and select them one by one. Okay, the cameras are connected and we can see the preview of the cameras in the software. When you create a new scanner and select the cameras for the first time, the exposure field of the cameras are deactivated. To have the exposure field activated, it is enough to close and reopen the software. Then all exposure and brightness settings of the cameras will be accessible from the software GUI directly. You can select different values for the brightness of the cameras based on your need. For the projector, I'm using a Casio laser projector with HD resolution. In this scan, I'm not going to use the hardware triggering option, so I already disabled it in the settings in the Advanced tab. Now the system is ready to take the calibration photos, but first let me describe how you should place the calibration panel on the table to have a better calibration result. For the first thing, you must consider the calibration range that you need for the scanning process. This means for what distance range the scanner should be calibrated and the cameras should be in acceptable focus. Then you must calibrate the scanner for whole of this range, from the closest to the furthest distance. For calibration, first place the calibration panel on the closest distance, then step by step move it back to fill the calibration range. For placing the calibration panel in front of the scanner, you should consider two important points. First, never place the calibration panel perpendicular to the cameras and projector. Always tilt the calibration panel back for about 30 to 40 degrees around the horizontal axis. Second, never place the calibration panel completely parallel to the scanner. Always rotate the calibration panel for about 30 degrees around the vertical axis. Now I place the calibration panel on the closest position to take the first set of calibration photos. Now the setup is ready, so I turn on the projector. Also, I turn off the fluorescent lamp to avoid any flickering issue caused by the lamp. I set the pattern of the projector to the focus mode. You can see the red color on the camera's view. That means the cameras are overexposed. So I reduce the projector brightness until I don't see any red areas on the camera's view. By experience, it is better to do the calibration process with a lower exposure, a slightly under exposure. For the calibration, I place the calibration panel in front of the scanner and make sure that both of the cameras and also the projector are focused well. And then after taking each set of calibration photos, rotate the scanner head to fill another portion of the camera's view. Now I enter the scale of my calibration panel. I am using a 50mm panel for this calibration. All things are ready. I press the capture button and take the first calibration photo. The first calibration photo appeared and all corners have been detected perfectly. You can visually check the corner detection quality. Now I rotate the scanner head to have the calibration panel on the right side of the camera's view. Another thing that you should always pay attention to is that all corners of the calibration panel should be visible in the view of both cameras. Now I take another photo and then rotate the scanner head to have the calibration panel on the left side of the camera's view. Then take the next calibration photo. To fill the bottom side of the camera's view, I bring up the scanner head and repeat the previous cycle to have the whole of the camera's view fulfilled with the calibration images. I take the calibration photos and rotate the scanner head in different angles to have the calibration photo in all views of the cameras. Now I move the calibration panel back on the second position and repeat the previous cycle. And for taking the last set of calibration photos, I move the calibration panel back and repeat the previous cycle. So far we have enough photos for an initial calibration, but we can enhance our calibration and make it more accurate in the depth or Z direction. So I tilt the calibration panel back for more than 70 degrees and repeat the photo capturing cycles, but no need to fulfill the camera's view in this step, and you can take less number of photos. And finally, after clicking on the calculate button, you can see the depth dimension is filled with the calibration photos perfectly. Software automatically calculates the calibration range, and you can see the closest and furthest distances of the calibrated range in these two fields. Now the scanner is calibrated and I can start scanning. I remove the calibration panel from the scene and place the black holder in front of the scanner to scan it. To scan dark and black objects, in the modified version of FlexScan3D, we must adjust some settings. In the settings window under Advanced tab, I set the gray mode enhancer to 3. Also, I set the shiny object scanning mode to 3 too. And increase the projector brightness until we don't see any red areas on the scanning object. Finally, press the scan button to have the first scan. The screen recorder software that I'm using for making this tutorial video loads the CPU of my PC heavily, and it increases the capturing and processing time of my scans. The first scan appeared, and it captured both of the object and the table at once. For removing the unwanted meshes from the scan data, I can remove them manually by selecting them and pressing the delete button on the keyboard. But also there is another automatic faster method to cut unwanted meshes. I switch to the scanning volume module. In scanning volume module, we can determine a cutting plane to filter unwanted meshes automatically. For this purpose, first, I remove the object from the scene and then scan the background. Then I select a flat region of the mesh and click on the Set Cut Plane button to create a planar cutting element with considering a planar offset. I tried different values for the offset parameter to make sure that all of the unwanted meshes will be removed. Then I switch back to the scan module and place the scanning object in the scene. By clicking the scan button, the scanner will perform the first scan. And after processing the data, you can see that only the targeted scan object remains and all other unwanted meshes are automatically removed. For this scan, I don't use turntable or any automatic positioning mechanism for the scanning object. I use markers for alignment. Software detects the markers on the object and match them with the previous scans to align individual scans to each other. In Next, I continue the scanning process and take several more scans from different angles of the object until it is completely scanned. The scan process took about 5 minutes, and I grabbed 16 scans to capture whole of this item. After the capturing process, I select all of the scans and fine align them. The scans are aligned perfectly and now it is ready for finalization. Again, I select all of the scans and then click on the Finalize button. For merging and finalization, there are two different methods with different functionalities and performance. For this scan, I use the Smooth Finalization method. Finalization takes a little time, and then we have a unified mesh as the final result. And finally, here we have the final mesh result with good surface quality and details. Even the 3mm holes are scanned well. To enhance the final scan result, I want to fill all small holes on the mesh. For this purpose, I go to the hole filling module. In the hole filling module, we can fill the holes automatically or manually. In the automatic mode, we can adjust the size of the holes to be filled using the autofill size tracking bar and visually observe which holes will be affected by the process. The affected holes are shown in blue. By pressing the autofill button, software starts filling the holes. If some holes are missed due to their bigger size, we can manually select them and press the Fill Selected button. And finally, in the end, I save the enhanced mesh and return to the scan module.